In March 2023, a team of Stanford researchers quietly released an artificial intelligence model that performed shockingly close to OpenAI's flagship conversational engine. OpenAI had spent years, hired elite research teams, and burned through millions of dollars in computing power to build theirs. The Stanford team did it in just a few days, for exactly $580. How they did it did not just shock the Silicon Valley establishment. It exposed a massive, systemic loophole that legal departments at Google and OpenAI are still desperately trying to close. To understand how a small team bypassed millions of dollars in development costs, you have to understand a process called knowledge distillation. Imagine you want to learn advanced physics, but you cannot afford the astronomical tuition of an elite university. Instead of paying for a 4-year degree, you hire a fast-writing scribe to sit in the lecture hall, copy down every single question the lead professor is asked, and write down every brilliant answer the professor gives. Then, you take those notes home and study only those question and answer pairs. In this scenario, the elite university is OpenAI's multi-billion parameter model, GPT-4. The scribe's notes are the API outputs, and the student studying at home is a lightweight, open-source model. But open-source developers do not just copy-paste answers manually. They have turned this into a fully automated pipeline. Using advanced agent frameworks, developers set up autonomous software pipelines where a frontier model like GPT-4 is instructed to generate its own complex prompts, answer them, and format the output into clean training datasets. According to research on large language model agents, this self-instruct methodology allows a developer to bypass the entire process of scraping the messy, uncurated web. Within hours, a single computer can generate tens of thousands of high-quality, structured instructional demonstrations. Developers use these structured outputs to align local models, compressing giant capabilities into tiny, deterministic runtimes that can run on consumer-grade hardware. This process has triggered a massive corporate counter-strategy. If you look at OpenAI's terms of service, the rules are explicit. You are forbidden from using their API outputs to build models that compete with them. But this is where we run into a fascinating legal fault line. A terms of service agreement is not a criminal law. It is a private contract. It only binds the specific person who signs up and uses the API. What happens if developer A uses the API, violates the contract by generating a massive dataset, and uploads that dataset to a public repository like Hugging Face? Then, developer B, who has never logged into OpenAI and never signed their terms of service, downloads that public dataset and trains a local model. Legally, developer B has clean hands. Why are developers taking these legal risks? Because the AI industry is facing a severe data famine. A recent large-scale audit of over 1,800 machine learning datasets published in Nature Machine Intelligence revealed massive chaos, systemic licensing mismatches, and a severe shortage of clean, commercially viable human data. With high-quality human text disappearing behind paywalls or tied up in copyright lawsuits, synthetic data generated by distillation has become an irresistible alternative. But developers who thought they found a clean escape route have run directly into a technical trap. Knowledge distillation is not a free lunch. Machine learning researchers have discovered that when a smaller student model is trained on a teacher's outputs, it becomes incredibly good at mimicking the teacher's style, tone, and formatting. It sounds highly authoritative, confident, and professional. But beneath the polished surface, the student model lacks the deep, underlying conceptual maps of the world that the teacher built during its multi-million-dollar training run. The student model learns to talk like a scientist without actually understanding science. It hallucinates with extreme confidence, creating beautiful, grammatically flawless nonsense. The issues run even deeper. According to research on generative AI red teaming presented at recent safety symposiums, a distilled model does not just inherit the intelligence of its teacher. It also inherits its hidden vulnerabilities. If a massive frontier model has a specific safety loophole, a subtle bias, or a vulnerability to a certain jailbreak prompt, those exact vulnerabilities are systematically transferred down to the student model. The student inherits the teacher's security flaws, but because the student has a much smaller architecture, it lacks the computational overhead to run complex internal safety filters to patch them. Despite these limitations, distillation is highly successful when developers stop trying to build general-purpose clones and start building targeted specialists. In specialized industries, like finance or medical document analysis, running a massive general-purpose model is wildly inefficient. Instead, companies use distillation to extract very specific capabilities, squeezing a narrow task execution tool into a small, 7 billion parameter local model. This targeted distillation can cut operational computing costs by up to 99%, making local deployment viable for small businesses that cannot afford to pay toll fees to giant cloud monopolies. The future of artificial intelligence will likely be decided by this technical and legal standoff. Frontier labs are already developing invisible, cryptographic watermarks to embed inside their API outputs, designed to immediately alert them if a competitor is using their text to train a rival. At the same time, open-source developers continue to build alternative architectures, finding creative ways to bypass these digital fences. Whether synthetic distillation is eventually ruled as a form of fair learning or contract theft remains an open question. For now, the wall separating multi-billion-dollar technology from local, free software has never been thinner. To stay updated on how this battle shapes the future of technology, subscribe, and we will see you in the next breakdown.